Welcome to all the Star Learner kids for the chapter called Motion with the part 5 where we deal in this chapter especially with graphs and equations of motion. So let us continue with concept of acceleration which we discussed in the previous class. So acceleration is rate of change of velocity. If we have a uniform acceleration in the previous class, now we are continuing from non-uniform acceleration. The body is said to be in non-uniform acceleration when its velocity is. The body is said to be moving with non-uniform acceleration if its velocity is increasing unequally, even though time is equally we have calculated. So let us try to see here in the other way that a body has non-uniform acceleration if its velocity is changing at non-uniform rate. At example, motion of a car in a crowded city where we have a heavy traffic and a speed or velocity especially changing continuously when we have a crowded or traffic. So try to see this a road on which you have a car going with variable speed, so which is having an non-uniform acceleration, sometimes increasing, sometimes decreasing. So we have another topic called retardation or deceleration or negative acceleration. We call retardation as negative acceleration. It means a body said to be retarded if its velocity decreases with respect to the time. So we can understand here retardation means decreasing velocity. Simply decreasing velocity. When there is a decreasing velocity, acceleration decreases. So decreasing acceleration is also called deceleration or negative acceleration. Now try to see the road in which a car moved fastly and came to a halt. So when it came to halt, it is decreasing its speed. If you apply brake, it means that speed or velocity is decreasing, due to which acceleration also decreases. So now position time graph. Position time graph is the graph which is related with acceleration, because velocity, we can take position time graph where graph is uniformly accelerated, means continuously increasing, and uniformly decelerated means continuously decreasing. So uniform motion has zero acceleration. So if you take a uniform motion between position and time, then acceleration is zero because rate of change of displacement is zero. And now we will have velocity time graph. Velocity time graph for uniformly accelerated and decelerated. If you see here, we have a graph for velocity time in which it is moving uniformly from V0 velocity point. So motion is positive, and we can say that acceleration is positive acceleration. In the same way, if the velocity graph is decreasing, it means it is deceleration. So during deceleration, we see negative direction of the line. Graph with a negative velocity. With a negative velocity. So motion in negative direction with negative velocity gives you negative acceleration, and the body is moving from positive to the negative. Motion with negative acceleration. So in this case, motion will be negative acceleration. So terms generally we use for equations are u, v, s and a. What is u? Initial velocity. What is v? Final velocity. What is s? Displacement of a body. What is t? Time period of a body. A body moving with velocity v and getting accelerated for t time for to travel x distances then our velocity is rate of change of velocity is our acceleration. Then from the first equation of motion, we know that acceleration is rate of change. Final velocity v minus initial velocity u by F against t. Then from the equation v is equal to velocity cross multiplying with t with a, we get. So from this we can tell that v is equal to v naught plus a is a first equation of motion. Now let us go to second equation of motion. So what is second equation of motion? We are going to derive is from average velocity, where average velocity is equal to initial velocity plus final velocity by 2. So V average is equal to V naught plus V2 by 2, where let us feel initial velocity as V naught and final velocity as V, or sometimes we can take U plus V by 2 even. From our previous video we can get average velocity concept, and distance formula is average velocity into time. Sorry, it is displacement. So displacement is average velocity into time. So in place of V average, we can use V naught plus V by 2 by using the formula displacement x is equal to V naught V into t. So from this, in place of V average, we can replace V naught plus V by 2 into t, where V naught can, in some texts or sometimes we can use even U as initial velocity. Then our equation replaced by the first equation, V is equal to V naught plus at from the first equation of motion. On substituting V value, we get x is equal to V naught plus at by 2 into t, where 2 times V naught is 2 V naught. So 2 V naught plus at by 2 into t. Then on splitting, multiplying with t and getting splitted with each term, we get x as V naught t plus half at square. We can also use in place of V naught u. Then our displacement equation becomes s is equal to ut plus half at square if we use s in place of x. So displacement is product of initial velocity into time plus half at square. This is second equation. So what is first equation? V is equal to V naught plus at, or V is equal to u plus at, where V naught and u represent the initial velocity. So from the equation we can understand the relation between displacement and time. Now let us go with third equation of motion. Now let us try to understand the third equation of motion. From the first equation of motion, we have V naught, V minus V naught is equal to at, and from the second equation, we know that average velocity is V naught plus V by 2. From this, V naught plus V will become 2 times V average. On multiplying this equation 1 and equation 2 together, it becomes V minus V naught into V plus V naught is equal to 280 into 80 into 2 VAV, where V naught minus V naught and V plus V naught become similar like A minus B into A plus B, which is the formula of A square minus B square. So we can write it as V square minus V naught square is equal to 80 into 2 V average. From this, we can also write V into T as x, where V into T is displacement. V into T is displacement, or else we can also replace velocity as displacement by time, where time get cancelled and we get the displacement, or else we can use s in place of x and u in place of v naught, and our equation becomes v square minus u square is equal to 2as. And this is the third equation of motion. So now kinematical equation, let us try to solve the same from mathematical into graphical form and try to analyze the same by using graphical method for the first equation of motion. Let us take for the first equation of motion velocity time graph. Because our first equation of motion is v is equal to u plus at, where there is a relation between v and t. So we take velocity time graph. So from v0 to v1, uniformly increased or accelerated body covered t1 to t2 time is total t time. So from a perpendicular distance, slope is perpendicular distance to the base, because slope gives us the velocity. So velocity is equal to perpendicular distance v minus v naught by base distance, it is t. Then acceleration formula, change in velocity by time, we get a is equal to bd by ad, and a is equal to ae by oc. Ae by oc, since bd value is equal to ae value and ad value is equal to oc value, so we replace bd and ad as ae and oc. And if we place oe as uh, o ae as oe minus oa, which is our ae value, by oc, that is equal to v minus v naught by t, which is our acceleration. From this, we can write v minus v naught as a into t, where v minus v naught is equal to at and v is equal to v naught plus at. Here v naught is the initial velocity which is already covered. In place of v naught, if we replace with u, it becomes v is equal to u plus at. This is the first equation which we can learn from the graph. And now let us try to learn the second equation of motion from the graph. From the same graph, if we find area of this trapezium OABD, it is half into product of the half half into base into height into sum of the parallel sides. Half into base is OC into sum of the parallel sides. Parallel sides are OA and BC. So OA plus BC, which is the formula of area of trapezium. Half into base into sum of the parallel sides. OA and CB are the parallel sides. From this we can write x is equal to 1 by 2 t into OA is V naught, OB is V. Since we know that V is equal to V naught plus AT from the first equation, on replacing we get 2 V naught plus AT, on multiplying with t, it becomes 2 V naught t plus AT square, and x is equal to V naught plus half AT square, which is the second equation of motion. Now let us come for third equation of motion. So what is third equation of motion? From this, x is equal to 1 by 2 OC into OA plus CB, which we have did similarly for the second equation. In this case, we are having V naught plus V. Now what we do is, from the second equation, we replace V plus V naught as 2x by t, 2s by t. From the equation 1, on replacing in place of t, it becomes V minus V naught is equal to V minus V naught is equal to AT, and multiplying first equation with second equation, we get V naught minus V naught, V square minus V naught square is equal to 2as, which is V square is equal to V naught square plus 2ax. If the position coordinate in the non-zero time is 0, say x naught, then V is V naught plus AT, x minus x naught is V naught t plus half AT square, where x minus x naught is displacement s. V square minus V square is equal to 2a into x minus x naught. Equation of motion for a freely falling body. Any body which is left freely on the earth, then it is called a freely falling body. So an apple falling from a tree is an example for freely falling body. In case of freely falling body, acceleration what it gets is equal to the acceleration of the earth, and the distance it covers is height of the apple. Height of the apple tree from the ground. So equation of motion therefore is V naught plus gt. H is equal to V naught t plus half gt square. Since S is equal to ut plus half t square, in place of S we can write H. So equation of motion, now by using concept of class 11 calculus, where we use differentiation. So according to differentiation, we do this equation as acceleration formula. A is equal to change in velocity v2 minus v1 by t2 minus t1, which is taken as delta v by delta t, which is equal to dv by dt, or simply dv is nothing but product of a into dt. On integration both sides, we get integration from starting initial velocity v0 to final velocity v or u to v, and time is from 0 to time to t time. Then integration of v0 to v dv is equal to a into integration of 0 to t dt, where a is a constant which will not be integrated, so it is taken out. So since a is a constant, it is uniform. Now on substituting integration of, okay, let's learn the integration. Let us try to learn the basics of integration to understand these concepts. So students, let's learn basics of calculus. So if you have any equation x plus 5, we can do differentiation with respect to x. Differentiation with respect to x, then d by dx of x power n, where this power value can be any real number or integer, is n into x power n minus 1, where the formula is n into x power n minus 1. So similarly, if we do this, d by dx of x, and we can also write the same d by dx to the 5. For constant values, differentiation of that constant is always 0. So this becomes d by dx of x, where power is 1, can be written as 1 into x power 1 minus 1, which is 1 into x power 0. Anything power 0 is 1, and as we already know from our basic maths, then 1 into 1 is 1. So I can write dx by dx as 1, and this is like d by dx of constant number 5 taken as 0. 1 plus 0 is 1. If I have x square, then d by dx of x square is having power 2, then n into, where n value is 2, n into x power n minus 1, which is 2 into x, which is 2 into x, and this value is 0, so 2x plus 0 will become again 2x. This is the way how we generally do for differentiation. Let us try to understand. X power n d by dx is n into x power n minus 1, and d by dx of log x is 1 by x. D by dx of e power x is e power x log x. D by dx of a power x is a power x. So this way we use for some logarithm, real numbers, or for integers. In the same way, if we take for d by dx of sin x, it is cos x. D by dx of cos x is minus sin x. So I hope you all understand how we do differentiation. Now let us try to learn the concepts of calculus from integration. So integration is generally adding all the small parts together to make it a larger one. So differentiation is making a larger one into smaller parts. So integration and differentiation is a reverse process. So we know from differentiation that differentiation of x is 1, d by dx of x is 1. if we do integration to this 1 with respect to the x, then we write it as integration of 1 x, which is reverse of this, that is x plus c. D by dx of x square is 2 into x power 2 minus 1, which is equal to 2x. Now if I do integration for 2 into dx, then 2x into dx, if we do integration for 2x into dx, then this can be written as 2 integration of x dx. Now integration of x power n dx can be written as x power n plus 1 by n plus 1. Integration of x power n dx can be written as x power n plus 1 by n plus 1. If you apply the same formula here, this becomes 2 into x power, where power is 1, so n value is 1, then this become, according to the answer, 1 plus 1 by 1 plus 1, which is equal to 2 into x power 2 by 2, numerator and denominator 2's are cancelled, then this become x square, which is exactly the reverse of integration, is the reverse of differentiation. So for integration of 2x, we got x square. So integration and differentiation, we need to learn some formulas. In that, the basic formulas which is needed for us is this integration of x power n dx and integration of 1 dx. So when we do integration, let us take like this. If integration of x dx is there, we write it as x power 2 by 2, since it is x power n plus 1 by n plus 1. Now if we have a limits, or if we have a limits from where to where this x value vary, then if we take x value from 2 to 7, then I write as bracket putting 2 in the lower limit and 7 as upper limit. Then I need to place this 7 and 2 in this value as 7 power 2 by 2 minus upper limit minus lower limit 2 power 2 by 2. Then this value becomes 49 by 2 minus 4 by 2, which is equal to 45 by 2. So on integrating from fixed level or limit values from where to where, then we can able to solve the complete part. We can able to solve that complete part. Now let us see how we apply this integration. The symbol of integration is this calculus. How we apply integration to find equations of motions. So if we take a graph with initial velocity v0 to the final velocity value v from 0 to in t time. Now this velocity is varied with respect to this time. Here velocity is varied with respect to the time. So let us see what is acceleration. Acceleration is change in velocity by change in time. So what I can write here is change in velocity is delta v by change in time as delta t. This is simply dv by dt. So acceleration is dv by dt. Then I can write a into dt as dv. If I apply integration on both sides, acceleration is changing from 0 to t time, and velocity is varying from v0 to v. From v0 to v, dv is varying, change in velocity is from v0 to v, and change in time is from 0 to t. In this change in velocity, in this time, we had an acceleration. So we are doing integration to the acceleration. Then here a is considered as x, like what we do integration dx. But here a is a constant value, So we write a 0 to t dt is equal to integration v naught to v dv. From this a into, now here it is constant value 1 into dt. So whenever we have integration of 1 dx it is x. If we have 1 dt then it is t. So I write here t from limit 0 to t. From limit 0 to t. Here this is equal to v from integration v naught to v. So from this I can write here a into upper limit t minus lower limit 0 is equal to upper limit v minus lower limit v naught. From this v minus v naught is equal to a into t, which is the first equation of motion. V is equal to v naught plus at on transposing v naught to the right side. So from this we can derive first equation of motion by using the concept of calculus. So I hope students understood how we apply integration and differentiation. Kindly go slow through the video and copy those formulas and try to understand what I have taught you there and apply it for this next part, which is a graphs from calculus, as with equations of motion by using calculus. Once again, try to see what I explained as acceleration is nothing but change in velocity by time dv by dt, where dv is equal to a into dt on multiplying dt to with a. Now integrating both sides, on applying integration from limits velocity from v naught to v and acceleration in a time 0 to t time, then v naught is equal to a is variable. Why a is variable? Because we are with respect to t, we are doing differentiation with respect to t, not with a. So a becomes constant for t, so a is taken outside. Try to understand, a into dt is there, dt is integrating term, so we are applying integration with respect to time, not with acceleration. So acceleration becomes constant for time, so a is taken outside. Then it is taken as a into 1 into dt. Now it is integration of 0 to t 1 into dt, where I have not written 1 there, but imagine 1 into dt is dt only. So now 1 becomes constant for integration. For constant value, integration of constant value is that function. The function here is t. So we write it as v naught v minus v naught. By applying upper limit and lower limit to the v become integration of dv in that v is taken, and integration of dt in the t is taken, then we get v minus v naught as at. So kindly please observe what I have taught, and I am giving you the final one as v is equal to v naught. Now we are doing the second equation of motion. In the second equation of motion, what is the formula of velocity? Is displacement by time. Displacement is change in displacement, change in position. Change in position is dx and by dt. On cross multiplying dx becomes v into dt. But we know v is v naught plus vt, which we have done this already by using mathematical form as well as graphical form, where we substituted for the second equation the first equation. The same we are doing here for integration even. So after substituting, we do integration here. On integrating both sides, this become integration from x naught to x dx and integration from 0 to t time. Then here on splitting the two terms as integration of 0 to t v naught into dt plus at into dt, and we know v naught is a constant, so it is taken outside, and a is constant, it is taken outside. But we are not taking t outside because t is the term which is there for the function dt there. T is already present in the function dt, so we don't take t outside. Only a is a constant, which is acceleration taken as a constant here. So on the next step, we know integration of 1 dx becomes x, and upper limit of x is capital X, upper limit is x, lower limit is x naught, so it becomes x minus x naught, and v naught into, here upper limit is t, lower limit is 0, so t minus t naught, t minus 0, where t minus 0 becomes 0 there, so it becomes v naught into t plus a into integration of t is t square by 2, integration of t is t square by 2, and on substituting t upper limit and 0, it becomes t square multiplied with a becomes at square by 2, which is the final formula. X minus x naught is equal to v naught. X minus x naught is equal to v naught t plus half at square. V naught t plus half at square. In place of v naught, if you keep initially u velocity, it is ut plus half at square. In place of x minus x naught, if you take s as displacement or x as a final displacement, then s is equal to ut plus half at square, or x minus x naught is equal to half at square, ut plus half at square. Then let us go with the final equation derivation by using calculus. Acceleration is dv by dt, as we know. In that, what we are doing is equation of continuity. So we can write as x term, where if you see here, dx can be cancelled. I write this as dv by dx into dx by dt, where dx in the numerator and dx in the denominator get cancelled. Then again I get my above equation dv by dt. But what I am doing is I am writing dv by dx into dx by dt as velocity, position, rate of change of displacement by time. Position by time is velocity. So position displacement by time is taken as velocity. So I write here v, and now what I am doing is multiplying v with dv and sending dx to the a and integrating on both sides. It becomes integration v dv, that is equal to a into integration of dx. But we know velocity varies from v0 to initial velocity v0 to final velocity v. Then on integrating v, it becomes v square by 2. By applying limit v and v0, it becomes v square by 2 minus v0 by 2, which is v minus v0 by 2. V square by 2 minus v0 by 2 is v minus v0 by 2, and a is taken outside, and x limit is x minus x0. So v square minus v0 square is by 2 is equal to a into x minus x0. So let me explain again. Students, let us learn second equation of motion. Second equation of motion by using v is equal to x2 minus x1 by t2 minus t1, which is delta x by delta t, can be written as dx by dt. Can be written as dx by dt. So from this we can write v into dt is equal to dx. In place of v, from first equation of motion, we can write v is equal to v0 plus at. On substituting, it becomes v0 plus at into dt is equal to dx. v0 dt plus at dt is equal to dx. Integrating on both sides, it becomes v0 integration dt from 0 to t time interval plus a is constant integration t dt, t from 0 to t time interval, that is equal to integration x0 to x, which is dx. So from this v0, I can write integration of dt as t from limit t to 0, and a into integration of t can be written as t square by 2 from 0 to t, that is equal to x from x0 to x. Then I write this one as v0 into t plus at square by 2, at square by 2 is equal to x minus x0. So I can write this one as displacement as s, initial velocity as u if it is ut plus 1 by 2 a into dc square, which is s is equal to ut plus half at square, resembling the second equation of motion. Now let us go for third equation of motion. Third equation of motion. So for third equation, let us take a is equal to dv by dt, change in velocity by time. I write this as dv by dx into dx by dt, where this x in the numerator and denominator can be cancelled. But what I do, I take this as a term which is dv by dx by dt can be taken as v. Then this becomes a dx is equal to v dv, integrating on both sides, x from x naught to x, v from v naught to v. Then this becomes a integration x naught to x dx is equal to integration v naught to v dv. This implies a into here x from x to x naught, and this can be written as v square by 2 from v to 0, from v to 0. Then a naught into x minus x naught is equal to v, this becomes v square by 2, this is v naught, v square by 2 minus v naught square by 2, where I can write this one as displacement s. Then a naught s is equal to v square minus v naught, v square minus v square is equal to s, which is the third equation of, so 2as is equal to v square minus u square. Now let us come for relative velocity. What is relative velocity? If one body is in relative motion with the other body with velocity, then we say that they are in relative velocity. The relative velocity of body A or object A with respect to B is rate at which A and B are changing their position. A and B together observing each other changing their position. If A and B having velocity VA and VB with object A and B, then their velocity with respect to AB is VA minus VB. Velocity of A with respect to B is VA minus VB. In a similar way, velocity of B with A is VB minus VA. Relative velocity is subtracting one from the other. Let us consider two objects A and B moving uniformly with velocity VA and VB in one direction, having a position change from x0 to from xa to xb at a time t from origin. Then the position after t time, they become x of t as xa plus vt, and xb of t as xb b plus bt vbt. So on subtracting xa and xb, relative velocity xbt minus xat is equal to xb minus xa plus vbt minus va whole t, where xbt minus xat is a relative displacement and time. So xb minus xa is relative displacement at time t naught. Then vb minus va is relative velocity of b with respect to a. Let us see now special cases when the two objects move with equal velocities. So here A and B are moving with same velocities, and when two objects having unequal velocity, then their graph appears like this. They meet each other at a point, and if VA is less than VB, means the velocity of the first object is less than the second object. They never meet, but they go in opposite direction, not in parallel. So they go in opposite direction, not in parallel. I hope from this concept of graphs and equations of motion, I think students, you understood clearly how to derive the equations of motion, either by using the concept of pure maths, or by using a graph method, or from calculus integration and differentiation process. I hope you will be watching the video twice and thrice to understand these concepts. Write down in the notes, practice how to derive them, and these derivations really help you in your exam. So wait for the next video, which will be on specially problems numericals of this chapter.